very important theorem and a very important topic also. Now the first topic is inscribed angle and second one is the intersected arc. What is meant by inscribed angle? Look carefully. The definition of inscribed angle. Student, if the vertex of the angle lies on the circle and the two arms are intersect the circle in 2 points, then the angle is called as the inscribed angle. Now look at this figure. Suppose that this is the circle with center O. This angle ABC, the vertex of this angle B is lies on the circle, and these arcs intersect the circles in any 2 points. This is the end point of that arc, so that this angle is inscribed in the arc ABC. So the definition of this in this figure, O is the center of a circle, point B lies on the circle, the arcs of angle ABC intersect the circle at point A and C. Such an angle is called an inscribed angle. म्हणजे काय, व्हर्टेक्स त्याचं कुठे पाहिजे, सर्कल होतं आणि दोन्ही बाजू कोणत्याही 2 पॉइंट मध्ये काय केलेलं असतं पाहिजे, इंटरसेक्ट केलेलं पाहिजे, म्हणजे छेदलेलं पाहिजे. तेव्हा जो कोन तयार होतो त्याला इन्स्क्राइब अँगल म्हणतात आणि याला इन्स्क्राइब आर्क असं म्हणतात. Here in this figure angle ABC is inscribed in arc. कोणत्या आर्क मध्ये? आर्क ABC या आर्क. This is inscribed angle. Then we see about intersected arc. Inter या शब्दाचा अर्थ सांगताय की आर्क मध्ये म्हणजे आंतरखंडित झालेला कंस कोणता हे आपल्याला बघायचं आहे. मग या सर्व फिगर जर आपण निरीक्षण केलं 1 2 3 4 5 and 6 या प्रत्येकामध्ये काहीतरी पार्ट हा इंटरसेक्टेड झालेला आहे. This is AC is the intersected here. Here is this portion is intersected. Here is AC is also intersected. In these 2 portions, in that this one is also and this one is also intersected here. In this also 2 portions, in that this part and this part is also intersected. And in this total circle is intersected in this angle ABC. So that all of these arcs are intersected arc. Now here is only one arcs are intersected, but look at this 3. There is 2 arcs. Here is also 2 arcs, and here is whole circle is intersected. So that in each figure, the arc of circle that lies in the interior of angle ABC, म्हणजे ABC angle चे interior असेल, is an arc intersected by the angle ABC. The points of intersection of the circle and mean that the point of intersection of the circles and the angle are end point of that intersected arc. या आर्कचे हे झाले end point, अंत्यबिंदू. Each side of the angle has to contain an end point of the arc. म्हणजे ते प्रत्येक साइड ही end point contain करते. Such arc is called as the intersected arc. This is inscribed angle and this is intersected arc. Can you understand this? Then we discuss about very important theorem. The name of that theorem is inscribed angle theorem. Okay, now we see the theorem. We discuss very important theorem. This theorem can be asked in your examination for 4 marks. The name of this theorem is inscribed angle theorem. The statement of the theorem is the measure of an inscribed angle is equal to the half of its intersected arc. I repeat it. The measure of an inscribed angle is half of the measure of the arc intersected by it. For this, I have to take its proof. So first I have to draw one figure. Now here is measure of an inscribed angle is half. So I have to first draw here one circle. Now the center of the circle is O. And angle, inscribed angle is, suppose that this is one angle which is inscribed angle. Suppose this angle is BAC. Then student, we write it's given such way that in given is the center. O is the center of circle. Angle BAC is inscribed in arc. In arc BAC, and arc BAC is intersected, and arc BAC is intersected by angle BAC. This is our given. Then to prove, the measure of an inscribed angle means that this angle is inscribed here. So that measure of this angle means that measure of angle BAC is equals to half of the measure of the arc intersected by E. Means that measure of arc half of this arc is intersected. Suppose that this point is here is suppose D. Means that this arc BDC is intersected arc. So I will write half of measure of arc BDC. Okay. Then I will write its construction here. Here draw radius or segment OC and segment OB. Draw the segment OC and segment OB. First I will draw these two segments, and also draw the ray passing through AO which intersect the circle at any another point. And here I will also write here, draw ray AO which intersect the circle at point, suppose that this point is E. Means that I have to also draw here one ray which intersect the circle in point how much? E. So take the point here, and this is point E. Now student, then in this triangle OAC, segment OC is congruent with segment OA, radii of the same circle. So that these angles are also congruent by using isosceles triangle theorem. Let these angles suppose that X, then they are equal, means that this is also X. So in this proof, first I will write here its proof. In triangle AOC, here is segment OA is congruent with segment OC because radii of same circle. Then therefore this angle OAC is also congruent with angle OCA because by using theorem of isosceles triangle. If these two angles are congruent, means that these two angles are congruent, let these angles having measure is, let angle OAC is equals to angle OCA is equals to how much? X degree. Suppose that this is our equation number first. Now student, look at this angle EOC. Now this angle is exterior angle of the triangle OAC. By using exterior angle theorem of the triangle, we have to discuss in 9th of this angle is equal to sum of these two angles. Means that x plus x becomes how much? This angle is 2x. So first I have to write here. Now angle EOC is equals to angle OAC plus angle OCA, because by using exterior angle theorem of triangle. You have to discuss in 9th standard this theorem. Mean that measure of the remote angle, measure of the exterior angle is equals to the sum of its remote interior angles. So I have to write here. Therefore angle EOC is equals to this one is the x and this is also x. X plus x is equals to twice x degree. Now student, this angle EOC is the central angle. EOC is the central angle. We know that by using the definition of the central angle, measure of this angle and its intercepted arc is same. So that now here, but angle EOC is a central angle. Central angle. Therefore, measure of arc EC is equals to measure of angle EOC. Measure of angle EOC means, reason is that by using definition of measure of an arc. Therefore, measure of arc EC is equals to twice x degree. Suppose that this is equation number 2. Student, when we observe equation first and second, we conclude that this OC is x and this is twice x. Means that OAC is half of this arc. So I have to write here OAC. Student, half of this means that this is also x and half of this one is also EOC. So I have to write here, means that half of twice x is angle x. X is this one is, so I have to write here angle OAC is equals to angle EAC is equals to half of measure of arc EC. This is equation number 3, and I have to write it from equation first and second. This is the reason of that point. OAC, that is angle EAC. OAC is x, means that this is EAC. Is also half of this arc EC, because this EC is twice x and this is x, means that this is half of this one. Right? This is equation number also 3. Then angle EAB ची व्हॅल्यू पण आपण आता EAB ची पण व्हॅल्यू आपण सिमिलरली काढू शकतो. So we take here similarly by drawing the segment OB. Here we write similarly by drawing segment OB. We can find out the value of angle EAB or BAE such that BAE or EAB. So therefore angle EAB is equals to half of measure of arc B. Suppose that this is equation number 4. Look carefully, student. If OB is joined, then OA is also triangle so that these angles are also equal, means that this is x and this is x. Then again this is exterior angle, so that by using exterior angle theorem this angle is twice x. Then this angle and this arc is same, because by using the definition of central angle or measure of an arc are equal, means that this angle and this is also equal, so that b is twice x, means that this is half of this one. So I will write EAB is half of this RBE. This is equation number 4. Then I have to adding these two ones, means that angle EAC and angle EAB, means that angle EAC and angle EAB. So simple one is. So adding this angle. So first I have to write here from equation 3rd and 4th. The addition of this one is angle EAC plus angle EAB is equals to half of measure of arc. This one is EC plus half of measure of RB. Then EAC plus EAB. Look here, EAC plus EAB means that total angle BAC. So I will write therefore angle BAC by using angle addition postulate. Sum of these two angle is equals to angle. Sum of these two is angle BAC. So that BAC is equals to, here I have to take common here half. Then in bracket measure of arc is C plus measure of arc BE. Measure of arc BE. Now look here, EC and PE becomes measure of arc BEC. So I will write here, therefore angle BAC is equals to half of measure of arc BEC, because arc addition postulate. Arc addition postulate. That is, these are BEC. Look here, BEC means arc BDC. So I will write the name of this one is, therefore angle BAC is equals to half of measure of arc BDC. And student, hence it is proved. Student, we know that this measure of arc BDC is also the measure of angle BOC. So when we solve the example, at that time we have to use this inscribed angle theorem is measure of angle BAC is equals to half of this angle also, means that angle BOC, because this BDC is equals to measure of angle BOC by using the definition of measure of an arc, means that measure of the arc and its central angle is equal. So we also use here measure of angle BAC is equals to half of measure of angle BOC. When we solve the example, at that time we will use this theorem. Student, I repeat, it's so simple but very important theorem. Look at this theorem. Again, the measure of an inscribed angle is half of the measure of the arc intersected by it. Means that this measure of this angle, means that angle BAC is equal to half of this arc. We have to prove here. So O is the center of circle. Angle BAC is inscribed in arc BAC. Arc BAC is intercepted by this angle BAC. This is vice versa statement. To prove is that measure of angle BAC is equals to half of measure of this arc BDC. For this I have to take construction is that draw the segment OC, segment OA, and draw ray AO such that which intersect the circle at point E. Draw ray AO which intersect the circle at point E. Then it's true. In triangle AOC, segment OA and OC are congruent. So that by using isosceles triangle theorem, these two angles are equal. So we know that remote interior angle theorem theorem, that is exterior angle of the triangle theorem. Measure of exterior angle is equals to sum of its remote interior angle. म्हणजे या दोघांची बेरीज ही या अँगलची असणार आहे. This is the central angle by using the measure of the arc. By using the definition of measure of arc, this angle and this arc is same, mean that this is also twice x. If this is twice x, when we observe it, this is twice x and this is x, mean that angle EAC is equals to half of arc EC. Similarly, when we drawing the segment OB, here is also isosceles triangle is formed. These two angles are equal, so that this is twice x, so that this is also twice x. So this twice x and this is x, mean that this angle, mean that EAB, look at EAB is half of arc B. Then adding these two, we get that 3 and 4. When we are adding it, we get that half of this arc EC plus half of arc B. Then this angle by the angle addition, postulate angle EAC plus EAB is BAC is equals to half of measure of arc EC plus measure of arc B. When we take its addition, then by the arc addition, postulate EC and B यांचे addition काय आहे? EC and B is equals to BEC, so that BEC and this BEC is also renamed as BDC, so that BAC is equals to half of measure of arc BDC.